We're going to be going through an installation process for the Prevectron lightning protection system. The first and one of the most important things we're going to look at is the grounding for the lightning protection system. It's based on 3/4 by 10 ground rods in a tripod, or you can use a chemical ground rod, or you can have a 3/4 by 10 ground rod with an inspection well. We want potential equalization. Every grounded system must be bonded into the lightning protection system so that everything in your building rises and falls at the same potential, therefore lowering the chance for damage. Down conductors, different ways of installing down conductors. This is an example of a down conductor coming all the way down to the floor and then coming outside to the ground. This is an example of coming down to another level, where we have a different level roof and coming out and what you need to do. Note the secondary bond to the piece of metal here with the roofing. This is coming down with structural steel. You have to bond it top and bottom with an 8-inch square bond plate, even though you're running the conductor all the way down, come through the footer, come outside to a ground loop out here and a ground rod. Roof level bonding. Anything within 15 feet of the main conductor run in a Prevectron lightning protection system must be bonded. This is this 3 square inch bonding plate. This would be used, for instance, on a piece of equipment. This is a pipe bonding strap. This is a secondary bond that would be used for something like a parapet cap or a drain. This is an 8 square inch bonding plate, which would be used for anything structurally that we'd be bonding metal. Lightning protection mast. There's different ways of installing the mast depending on your application for your project. This is a weld mount base. This base here in orange is welded onto a structural beam or column of your building. Then there are 2 down conductors in PVC that go opposite ways out, down to ground. You have a piece of conductor coming through the bond plate, which is an 8 square inch bond plate, and the mast is used for the down conductor to the bond plate, to the conductor, to the down conductors and out to ground. This is an example of a side mount mast. When we have something like maybe a dog house up on top or something that we can use to mount side to it, we use a series of channels or struts that we use with stainless steel rod that actually hold the rod or the mast over towards the structure itself. Again, we have a bond plate on it and 2 down conductors coming down to grounds. These are different models of the Prevectron that you have available. Each one of them have a different amount of capacitors inside of them, and therefore their strength goes from small to large, and the large, of course, gives you a larger radius of protection than the smaller units. We use a combination of them to make it economical as we can at an installation. Ground system. Here's some of the things you must understand. Coordination. You need to coordinate with everybody that's on that job that's putting anything in the ground. You need to pick out a location and make sure that you have a place that everybody knows and that they'll stay away from. The requirements that you're going to use, either 3/4 by 10 ground rods, chemical ground rods, or a ground loop, the type of terminations you're going to use, an exothermic weld, a Burndy, a mechanical clamp, potential equalization, making sure that all of the grounded systems are bonded together, and documentation, pictures, drawings, as-builts. Coordination. Establish the plausibility of ground locations specified by NLP. We can only see so much on a piece of paper. You get to a job site and see that you can't put it where we say to put it, then you need to contact us. But do not modify the location without our approval. Coordinate sleeve locations with the general contractor so that you can get it in before it's formed up. Establish where the finished grade will be. This is very important. You want to be below finished grade when you're putting these in. Install at the form-up time to avoid any trenching potential and damage for other buried systems. So if you've got a ground loop and it's already dug out around the foundation, you can probably lay it in around that dug up part of the foundation. You can also get a lot of your stuff down and out and grounds in before they backfill. Install bonds to the structure at form up. So if you've got, for instance, structural steel, or you've got rebar that you want to get to, that we need to get to, then that's the time to do it. Location. Avoid other conductive systems like incoming telephone lines and data. Avoid areas where people will congregate. It's not a good idea to be in a place where people are going to come outside and smoke, because you're going to have step potential around these grounds. It must be at least 12 inches below finished grade, must be a minimum of 24 inches away from the foundation and the footing, and must be installed at the structure's exterior, not interior. Terminations. Options: driven rods, buried plates, chemical ground rods, ground loop, counterpoise, or earth electrode system. Driven rods: 3/4 by 10 copper or copper clad, a minimum of 3 per down conductor, a minimum of 10 feet apart, a minimum of 12 inches below grade, a minimum of 24 inches away from the footing or foundation walls. This is a typical ground, delta ground that we have, 10 foot away, 10 foot away, 10 foot away. This shows it being done, accomplished with a Burndy high ground. We can also go in a straight line. This example here is of an exothermic weld, exothermic weld, exothermic weld. Buried plates, here's the requirements for that: a minimum of 2 square feet in area, a minimum of 20 gauge thickness, a minimum of 3 per down conductor, a minimum of 10 feet between the plates, a minimum of 12 inches below grade, and a minimum of 24 inches away from the foundation walls. Ground plates need to have something so we can get down to check to it. We have inspection wells that you can get down and put a tester onto that wire, and you can find out what your ground resistance is. Same type of spacing we had before, or you can go in straight line if you have to. Chemical ground rods, we have a straight shaft, or where we have bedrock that's very close to the surface, we can use an L-shaped rod. Chemical ground rods, installed in an augered hole or trench. The straight would be an augered hole, the trench would be dug, probably by hand. Backfill with bentonite, soil, and water mixture. There's a whole process of how you mix that. It's a lot like mortar. You mix it up into a base that looks kind of like cake batter, and then you put it around it. There's a minimum of 1 per down conductor, and spaced no less than 2 times their length. A ground loop. A ground loop conductor encircles the structure's perimeter. Ground rods are required at each down conductor termination. Test well is required at each down conductor termination, and ground rods are required at an average of intervals of 100 feet apart. So you've got some requirements if you're going to use a ground loop. Potential equalization bonds to the structure. We're talking rebar, we're talking structural steel, anything that we need to do to make that all the grounds that are there are in common. This happens to show a water line, which is very important. This is to the electrical system, where we've gone in and bonded to the electrical ground rod, bond to the electrical service ground. This is an incorrect way to do it, meaning this is our down conductor coming directly over. This is incorrect. Again, here's a down conductor coming over to that. You don't want to do that. What you want to do is take your down conductor into the ground, then come across and get onto your electrical ground. Ground system, we have to have the resistance below 10 ohms. We want a 3-point test. This is a typical way to do it. Documentation. NLP ground rod resistance test form. You need photo documentation of the installed ground and the system equipment. You need photo documentation of the bond connections, photo documentations of stub-ups. Transmit to the GC and get them to sign off on the installed equipment. This will be good as far as everybody having what they need to have to not damage your grounds. Very important. This is an example of a photo submittal. This shows all of the items that they photographed that they put on a piece of paper and sent into NLP. We keep all of this in your records for your job. Down conductors. You need to coordinate the locations, and you also need to make sure that you understand the requirements that you have for your down conductors. Coordination. Do not modify NLP design designated locations without approval. It's not that we're going to make you change it someplace. We need to know it. Verify plausibility of locations early on. Plan ahead. Don't get covered up. Very good item. Coordinate penetrations with roofing contractor. It's the roofing contractor's responsibility to take care of those roofing penetrations. It's good to get to know them. Locations. Avoid stairwells, avoid elevator shafts, and be aware of areas designated as plenum airspace. We want to stay away from those when we can. Down conductor locations. Avoid low voltage systems. You don't want to run it right by a telephone line. Avoid data lines. Avoid communication lines. Any of those type of things is going to have some type of interference or transfer of voltage when there is a strike coming down on the lightning protection cable. It'll be induced into these small cables. It causes havoc. Down conductor requirements. They must be a main size conductor. Must maintain a downward or horizontal path to ground. Each air terminal shall have a minimum of 2 down conductors. Each additional air terminal shall have a minimum of 1 additional down conductor. So if you have 3 terminals up there, you would have 3 down conductors. Separate down conductors as wide as possible. Very important. Down conductors shall be run in or along building extremities. So we want it outside, not the inside of the building. Conductors may not be run through the building interior. This is incorrect. We're inducing a lot of voltages, induced voltages into all kinds of systems this way. This is another incorrect way. Again, you're coming down through the building and then taking your grounds out. That's not the way to do it. Take it out and down. Down conductors shall be kept short and straight. You don't want to be running all these 90s through here because you're going to cause problems with the down conductor and the flow of the lightning charge out to your grounds. Each additional terminal shall have a minimum of 1 additional down conductor. As I said before, if we have 2, then we have 3, and we go on again. If you have 3, you'll have 4. That's what we need to have. Down conductor shall maintain a horizontal or downward path to ground. Here's some acceptable bends of a conductor. This is an 8-inch radius with a 90. This is a 45, that's acceptable. And here's a 45 or 135, it's acceptable. Less than a 90, that's unacceptable. For every 360 degrees of bend, a pull station or J-box is required. Pull stations and J-boxes must allow for correct conductor bend. So if we come down here and we've got 360 degrees, we're going to have to put a J-box in here somewhere. Down conductor requirements. Exposed down conductors shall be fastened every 36 inches on center if it's run bare. The bottom 10 feet of the exposed down conductor shall be protected with conduit. Metallic conduits shall be bonded to the down conductor at the top and the bottom. Down conductor shall be bonded to structural steel at the top and the bottom. Here we have, again, a weld mount type base. We have the conductor coming off to down conductor in PVC. We can take it on out. Here's coming down structural steel. As you can see, here's a bond to the bottom. There will also be a bond up here to the top. Roof level bonding. Metal objects of conductance within 15 feet of an exposed lightning protection conductor shall be bonded to the lightning protection system with a main size conductor. Metal objects of inductance can be bonded with secondary, but the same requirement, 15 feet. Primary bond connections. We have an 8-inch square bond plate, we have a 3-inch square bond plate, and we have a pipe strap bond. Here's what we're bonding. Rooftop equipments, exhaust fans, structural members, roof vents, mechanical equipment, mechanical objects of conductance. Here's a prime example. We have some of these mushroom top roof fans that are up here. This is a main conductor coming over to a 3-inch square bond plate, making that bond. Here is a pipe. Again, we're coming with a main size conductor and using a strap around it. Secondary bond connections. This would be like a number 6 copper. Here's where we use those: flashings, door frames, roof drains, ungrounded objects, metal objects of inductance. Here's an example. This is a cap that goes over a drain. It needs to be bonded. Again, this is a down conductor. This shows going to a different level of the roof. Come down, come in, down, and you're on the second level of the roof. This is a typical example of why and where we need to bond. Here's a chiller unit, here's a roof drain, exhaust fan, RTU, rooftop unit, VTR. Anything within 15 feet this way, 15 feet this way, needs to be bonded. Roof drain to be secondary. Everything else that we have here would be primary. Bonding conductors shall be fastened every 36 inches, whether primary or secondary. Roof-mounted conductor. Get authorization from the roofing contractor on the adhesive to be used and the method of installation. It's very important. You got to do that first and up front. Lay out a path of the conductor, mark every 36 inches, lay down the clips at each mark, and prepare adhesive for a 2-part. Most of them use a 2-part type of adhesive. You've only got a certain lifetime before that sets up. So you've got to be prepared. You can't be doing that just off cuff. These are the 2-part type of adhesives we're talking about here. This is Carlisle, this is Firestone. This is stuff that you can use sometimes, but you have to have approval. You don't have to worry about this stuff setting up quite so quick. Conductor fasteners must completely encircle the cable. What I mean by that are these 2 ears, or whatever you want to call it, must completely encircle it. The cable goes through here, this comes together, and the screw goes through here. Mechanical fasteners must be copper or stainless steel. Wire ties or tie wraps are not acceptable. Lightning protection mast. Okay, coordination. Do not move the mast location without NLP approval. We have a certain calculated area of protection that we need to make sure that we can keep. Coordinate attachment with the general contractor. Coordinate penetrations with the roofing contractor. Plan ahead. Don't get covered up. Mast types: hinge base, side mount, shoe base, and direct burial. That's the types mainly that are used. Hinge base. It's mounted to steel. Again, here's a weld mount base, as we've talked before. It's also mounted to concrete, like we showed you before with the 2 plates. Mounted to a bar joist or gravity mounting. Steel mounting system. This is what we're talking about. We're talking about a weld mount base here. This has to be welded down here to that column. It'll tell you exactly what needs to go. We'll have this in detail on our submittal drawings to make sure that you can see exactly what needs to be done. Gravity mount system. This is a channel here with weighted concrete blocks that can be set in place depending on how tall the mast is, depends on how many of these you have to use. And also what your typical wind is in that area. This is a weld mount base. This is how you must have the fasteners set up. This shows the hinge being over these fasteners, and this shows the leveling. You have to level this just like you would be leveling a typical light pole. This shows the cable going out. What you have to do if you're on an existing roof, you have to go ahead and you've got to move all of the rock away so that you can use your adhesive here. This is an incorrect installation. Obviously, what's happening here, we're starting to get corrosion because there's no drainage. Here again, there was nothing put on behind this bond plate, so we're starting to have corrosion between them. It needs to have something like no locks. Side mount mast. Here's an example of a side mount mast being used on a doghouse, which is using its structural steel to help mount it and support it. side mount exploded view. This you will also have when you get your plans in. This will show you exactly how to install this side mount mast and how to support it. It'll give you a list of material down here. It'll show you how that list of material needs to go together. This is an example of a Prevectron using a type of support pole pipe to get above a certain area, and this is a special application. This is an application on top of this tower. This is a large shoe base type that's used. This one is actually up at the IBM campus in Boulder, Colorado. This is when you don't want to put the lightning protection directly onto the structure. So you help by not inducing as much voltage into the structure as you would with the lightning protection on it. This is on a flagpole. This happens to be in Tulsa, Oklahoma. This is at a golf course. Prevectron's right up here. This is where they had the PGA Championship, and we put the Prevectron on it. Air terminals. Do not lift the pole into place with the air terminal on it. Do not allow the poles to rest on the air terminal. That's just not good. Do not modify air terminal in any way. Do not attempt to open air terminal's housing. It's sealed. Make sure the lower electrodes, the air are rotated outward. There's a whole explanation inside of it, but you've got to make sure it happens. Securely tighten the air terminal into place with the provided jam nut. Lock air terminal into place with the provided set screw. We've got two ways of making sure that it stays in place, and those are very important. When we were talking about bringing these out, when it's shipped like this, with all of these wings inside. You have to turn them out, and then you need an Allen screw or Allen bolt to sit there and turn them out, and this is the way it should look before you install it. Here is our website. This has a lot of information not only on Prevectron, but also on Franklin and on chemical ground rods or whatever. We can go through Prevectron system details. We can give you Franklin system details, catenary system details, mass details, down conductor details, grounding details. These are all downloadable and can be used on drawings for architects and engineers. We have them in CAD and we have them in PDFs. We have the testing, we got the air terminals, we have strike counters that are available, we have different masts that you can choose from, the different mounting bases, all of the mounting hardware, the conductor, the connectors, the bonding, and the grounding. All of that will be there online on Prevectron 4. These are all a very good example of the material that we manufacture. This is the Prevectrons. This happens to be one of the things we have a patent on. It's called a flathead. It's a safety type of air terminal. Different types of air terminals, bases, through roofs, cables, braids, testers, and strikers. It gives you a pretty good example of how you need to install the Prevectron. And I hope that if you have any problems, give us a call.